2024 AMC 8, question 20. All three vertices of the cube PQRSTUVW, so this cube below, if you pick any three vertices, you can form a triangle. As an example, if you connect the PQR together, you will get a isosceles triangle. Now the question is, how many of such triangles are equilateral and contain P as a vertex? So two conditions you need to meet. It has to be equilateral, and P should be one of the vertices. Some quick definitions. Isosceles triangle means two sides are equal. For PQR, PQ and QR are equal because they're both side length of a square. So PQ and QR are equal, and that's why it's isosceles triangle. Equilateral means three sides are all equal. So all three sides equal. And to build on top of that, that also means all angles equal. So all angles 60 degrees. All angles are 60, all sides equal. All right, and you need to have P as a vertex. This is a 3D geometry question. And 3D geometry is very, very hard because the question generally is drawn on a two-dimension paper. A 3D shape on a two-dimension paper is really hard to picture, right? It's very hard to draw the picture to be exactly precise, which means you need to figure out ways to simplify this question a little bit. Like this one, how do you simplify it? Well, you start from P and try to form some triangles to get a trend or figure out what's inside. How can I get a equilateral triangle? And then, based on this insight, you can figure out how many such triangles are there. So PQR apparently doesn't work because PQ equal to QR, but PR is a diagonal, which is longer than the other two, so it doesn't work. And you may be able to quickly find PQW, PQV, or PST, PSR, none of them works. Because for each of them, you would get the side lengths of a square, like PS. And then you would get side lengths of another square, for example, PSR, and then PR is never going to be equal to them. So quickly you will find it looks like if you use any of those lengths, side lengths on a square from P, it doesn't seem to be working. Instead, one example that works, and again, this is where you leverage some easier part of the picture. For example, to get one thing that works, I'm able to say PRT seems to be working. Well, PR is a diagonal of the top face. PV is a diagonal of the front face. And RV is the diagonal of the right face. So triangle PRV works. Not only we want to find the example that works, but you also want to get an insight. What's inside here? What sort of triangle would work? You might be able to get it. Now, to make this triangle equilateral, I can only use three diagonals. So I need, or we need, three diagonals. Why? Because you tried a bunch of triangles. PQR doesn't work, PSR doesn't work, PWT doesn't work. What else? PST doesn't work. Anytime you use a side length, it doesn't work. So you can only use diagonals. That's where we are simplifying this question, because now you don't really need to draw the picture. It's harder and harder to draw stuff on a 3D picture. Instead, what you can do is to say, okay, starting from P, what are the diagonals I can find? So PRV is a good example. Now, from P, how many diagonals can I draw? Well, you can draw PR. You can draw PV. You can also draw PT. Anything else? Not really, because P belongs to top face, left face, and front face. So there are 3 diagonals you can draw. And what's next? Well, what's next is you need to pick any 2 of them and then form a triangle by connecting the other 2 points. For example, how to get PRV? You pick PR, you pick PV, and then connect R and V, you will get PRV. So let's write this way. PR plus PV is PRV. What I'm trying to do here is try to make it more abstract so that you don't need to try to draw this out in the picture. Same thing, you can do PR, PT, so PR plus PT equal to PRT, which also works. Actually, to be honest, PRT is much harder to draw. That's why if you realize that I just need to make sure there are 3 diagonals, it's easier to see it. And then PVT. Same thing, you have PV, you have PT, and then you get PVT, which also works. And that's it. Because you have 3 diagonals, take any 2 as a pair, well, PRPV, PRPT, PVPT. So the answer is 3.